My name is Steve Adler. I work for IBM as IBM's Chief Data Strategist, and we're here this morning to talk about the XMILE System Dynamics standard for modeling. And my role here is to introduce to you what System Dynamics is, what XMILE is, why it's important, and why this standard is so important. And to do that, I want to tell you a little bit about my own journey in learning about system dynamics. And it started about 5 years ago when we at IBM created a system dynamics model for the city of Portland called a Smarter Cities simulation model. System dynamics is based upon the idea of systems thinking, that there are lots of different systems in the world, ecosystems of interlinked and interconnected ideas and components that transcend the simple notion of cause and effect, in which each effect can have tertiary causes and effects with feedback loops. And most often, system dynamics models are used to create a model of the world as we see it, and then run policy simulations against that model to evaluate how different ideas can change an environment. The model that we created for the city of Portland had something like 3,000 different formulas in it. It was so large and so complicated, modeling the 13 different city departments and hundreds of different city programs, that by the time we created it, we could barely understand the model in its complexity ourselves. We had to slim it down to about 600 formulas. And even then, city officials found it very difficult to understand exactly how the model worked. Its beauty was in illustrating complex interrelations between departments. Things like how short walking trips could not only impact human health and services in the community and shopping, but also carbon emissions and obesity and a whole variety of different tertiary consequences from just doing short active trips. Things like that were really revealing to city officials, but they actually grew quite concerned that the model was so complicated that they weren't sure they understood how the formulas were revealing the outcomes. And as I began to explore this idea of systems thinking, I thought, there must be a way of providing a more standardized approach to modeling. And as I looked at that model and other models, I began to understand that many system dynamics models are more art than science, and that there were no real standards in the industry as to how models were created or documented or communicated to other modelers or to people who use them. And that's when I became interested in proposing the idea of an open standard for systems dynamics modeling. Open standards are a great way for creating common and reliable tools for transforming industries like the system dynamics industry into a widely adopted and understood discipline. And that's the purpose of this, of the XMILE standard, is to help transform a small but very, very important industry into a far more widely used and widely understood analytical tool. And I think all of us today are aware of how important analytical tools are. I think we're increasingly using big data and analytics to illustrate complex relationships in our world, whether it's climate change or business or the interrelation of social systems in our lives. And the more we become reliant on these types of models, the more important it becomes that the models themselves are open and transparent, auditable, and understandable. I think that's the real importance of this open standard for systems dynamics modeling, is we're transforming this art of designing algorithms in a graphical language into an XML-based language that any developer, any modeler can learn and use from any model that's created by another modeler. And the vision here is that over the next few years, we hope to create libraries of auditable, open, system dynamics models and simulations that developers can trade with each other, can articulate to the public, that become a part of how we understand our world and how we simulate the impact of policy on complex ecosystems. And that's why I'm really delighted that after a great deal of work in our technical committee, we're bringing to you today our first version of the XMILE Open Standard for System Dynamics Modeling. I think this is a really important contribution, not only to the system dynamics industry, but also to simulation models in general as a first version of this XML-based standard. And I hope that I want to turn it over now to my co-chair, Kareem Shishakli, to talk to you about exactly what's in the standard and how we created it and what we're doing with it. Kareem?
Thank you, Steve. I am going to talk a little bit about some sample applications and also a little more about system dynamics before I get into the details of XMILE, just to expand upon what Steve has already told us. There are many, many important applications of system dynamics in models. For example, this simple phone application is used to for people to play with what kind of emissions reductions we have to make to meet the goals. But these exact same models are used by the negotiators that are meeting in Paris, for example, to figure out the emissions for each country. Models are used in healthcare to try to figure out ways to reduce the cost of health care and also to improve outcomes for people. And there are different possible options that you can play with in this model that let you tell you what's going on. It's used in the energy field, for example, to help figure out how to store wind energy and use it later because wind energy is so variable, as you can see here. It's used for regional planning. System dynamics models are used to try to figure out how land use is going to change over time and what policies might be implemented to encourage land use change in the direction that you want. It was used in this online environment to try to predict who might win the election in 2012, and this was based on you put in percentages of how many people were going to vote in each area, and it would tell you which states would swing which way, and that was a system dynamics model that did that as well. So all of these use system dynamics. There are several other applications. I just used a very, very small sampling. And system dynamics deal with interactions between things. So here we have a little system where we have customers interacting with suppliers and competitors. Here we have our little model of what's going on for CO2 emissions, greenhouse gases, and climate change. Here we have a little model about developing a credit card business. So why use system dynamics at all? It models entire ecosystems. It looks at the complex feedback between these interconnected systems and lets us understand what's going on in these systems that we can't really appreciate within our minds when we try to simulate ourselves. So this is, in fact, a picture of what's going on in urban dynamics, which was a study that looked at why America's cities were decaying and what might be done about it, and there were complex feedbacks that were going on between the systems, for example, between the population, business, and jobs, population and housing, how much land was available was really critical, and these are the relationships that are in that model, but these relationships you put into a computational engine that then can tell you what the outcomes might be based on those relationships. We believe in system dynamics at the structure of the system, and by structure we mean the feedback loops. These are feedback loops. It determines the behavior. So here I have a simple model of cattle, a population of cattle. Some are being born and some are dying. So the more cattle are born, the more cattle there are. The more cattle that die, the fewer cattle there are. And and how much grass there is determines how well they survive, and we can get several different behaviors out of this over time. We're looking at behavior over time, and the system can be stable, the system can be growing, the system can be declining, the system can grow in a way that it overshoots the ability of the grass to regenerate itself, and then it can collapse. We also use system dynamics because we can look at tertiary effects of policies over a very long time horizon. So we may choose a policy that in a short time horizon looks really good and looks like it's going to work, but if we look at a longer term time horizon, it actually comes back and causes us problems. As I said, we look at dynamics over time. We're looking at the GDP from energy sector in Alberta, Canada that was predicted by a system dynamics model, and this is what it looks like in the GIS over time. You can see it's growing tremendously up in this area here, which is and roughly unchanged in this area over that time. One of the things system dynamics does for us is it exposes our implicit models of what's going on. We make assumptions about what we're doing all the time, and we don't always understand them ourselves. We don't understand what we're assuming and how that's getting in the way of our figuring out what's going on. So one thing the system dynamics does is it helps us share our understanding not just with ourselves but also with other people and to get feedback about what's going on. It also reduces misunderstandings. And as a quick example, I may have a simple understanding of how price works. I'm not saying either of these models is right, by the way. These are just simple examples that are discussion points. And I may think that if price goes up, my demand will go down, which means my revenue will go down, which means my profit will go down, which will just cause me to raise the price again, and I get in a vicious cycle. Someone else that I'm talking to may think instead that if price goes up, my revenue goes up, my profit goes up, and because my profit goes up, eventually my price might come down again. So those are different viewpoints and different worldviews, and by putting this down, we can discuss it instead of keeping it in our heads, and we can also build models around what the implications would be if that were the case. It allows us to safely test policies and validate what outcomes we get. So in the case of Rethink Health that we looked at, I showed a simple example earlier. In healthcare, we can look at if we give pathways to advantaged students, will that help? In looking at climate change, if we sequester from afforestation, will that help? And how much, this is a control to do it, and this is what might happen as a result. We have our previous run and what happens now, we've actually lowered the global temperature. If we change the percentage of the electorate, which is Latino, what happens to our outcomes here? And we can just test these very quickly and easily. So XMILE itself is an open standard for system dynamics that's being developed, that was developed. We're ready to vote on it becoming a standard. It is an XML representation of system dynamics models, and it provides a standard language as well as a means to extend that language. It also includes the ability to show a stock flow diagram, which I'll show soon, which is a critical part of system dynamics. So we have ways to display that. And also we have interactive components that let you change settings and look at results. So we're doing this for OASIS. I don't need to spend a lot of time of why open standards are important, but we think one of the big issues is interoperability between different platforms that we have, and there are new ways to create applications that aren't there. And in particular, we're interested in more innovation and competition within system dynamics, and also more collaboration. So the technical benefits for us is that for the community in system dynamics, as well as those who want to use these models, who we hope are a lot more people, in the sense that we believe that system dynamics models, as Steve was talking about earlier, allow you to see things from a broader view and allows you to look at tertiary effects more directly and make better decisions in the end. So it's a very strong decision support tool. So one of the benefits is we'll be able to share models more easily. We'll be able to archive models because there'll be a standard format. We'll be able to reuse common components, and they may come from different vendors. So here I'm putting a bunch of components together, and I have this part I took was originally done in one vendor's platform, and this was done in another vendor's, but because they're in XML and in XMILE, I can share them and I can build myself something more complex using those pieces from different places originally. So we can create libraries of things that people can use. It opens development of add-on tools. We don't have closed proprietary systems anymore. And in that sense, it will make System Dynamics more accessible to more people, so more people can use this within their businesses, within their companies. We think that if we have XMILE, we'll be able to integrate more into business intelligence systems and with big data as well. So I'm just going to go through very quickly some technical details for those of you who are joining just to find out what we're doing about this. We decided to implement a core subset of the System Dynamics functionality because each vendor has their own things. We don't actually require a stock and flow diagram to be included. We just need the ability to simulate it. We don't require advanced language features, but they're there optionally, which I'll talk about a little more in a few minutes. And we allow you to extend it both in how it's represented and how the behavior, the simulation occurs. And one of the goals was to have a small file size that was sort of human readable and editable if necessary. We also included a little metadata. We would like to expand that in the next revision, but you'll see we have metadata in there that helps you learn stuff about the models that are there. The parts of the standard language that we include are the stocks and flows and auxiliaries. So if you talk about System Dynamics, it's based on, this is a little System Dynamics model here. We have a stock of savings, and that gets increased by the interest we get, and the interest we get is at some interest rate, and it's compounded over time. So interest rate times our savings gives us the interest, which increases our savings, and that's what the picture would look like. So we support those basic elements. We support graphical functions. If you don't know what that is, it's instead of using an equation, you can draw a picture of what the function does. We support grouping things together, units for each of these things, presumably dollars or euros for our savings. There are a number of built-in functions for our equations, and there are several optional extensions that you're allowed to include but do not have to be supported if someone doesn't have them. And the most important of these would probably be macros, which allow us to extend the language, conveyors and queues, which allow you to do discrete simulation inside a System Dynamics model, submodels that let you break it up into separate pieces and build models hierarchically, and arrays, which allow you to look at, for example, different locations in the same model. This is what a sample model looks like in XMILE. We have this is just the model part, not the drawing part, but in this simple model we have a group of hares, and they're being born and they're dying over here, and some of them are getting killed by lynxes based on, this is a relationship here, based on what the density of hares is. The higher the density in the area that's there, the more get killed, and the higher the death rate. So this is how many get killed, and this is how many lynxes there are, and together they wipe out the hares. But over here is the XMILE. We have a model, it has a name, it has a variable section that talks about the equations for this, and we have the stock named hares. This is the equation, it's a constant. It has an inflow right here, it has an outflow right there. And then the flow has an equation, that's the births. The flow here has an equation, that's the deaths. Down here we have an auxiliary, which is just used for calculation, and this is hare birth fraction. The \n is a new line, and that's the value. And down here we have a graphical function. This is hares killed per lynx, and it gives us the minimum, the range for the x and the range for the y, and then the actual y points. So we know there are however many points, we figure out what the x points are automatically. And this is what the graph would look like, increases. There's a header in there that includes all the options that I talked about earlier. If we talk about arrays, we talk about the largest dimension as well. We even say whether or not we use views that let us include the picture of the model and what's going on. The model tag we just looked at a minute ago, I just showed the variables, but there's also a view section which tells us information about how to just draw them, which we'll look at in a second. And I just showed this before, but just to be really clear, oops. Oh, it lost the annotation here. But a stock, a flow, an auxiliary very quickly. And we have a number of built-in functions that are supported. We also have the ability to expand the built-in functions and what's included using macros. So here we could make a more general log function on any base using this equation. And then here's documentation to help the user understand how to use that. We also, on the display and interaction of models and things, we control layout and styling of the model. So here I can change the color to all this to purple in the view section, and I can say where the stock is located. We have cascading styles, which I'll talk about more in a second, and we have ways to, control what's happening in the model by changing parameters, and also look at what's going on as the model's continuing. If we look at it more carefully, the view has, there are different types of view. There can be a stock and flow view. There can be an interface view that has kind of the control objects on it. There can be vendor-specific views. There can be window views. They have a size. They have what the zoom level is. They have a background color. And the 00 is in the top left of the view. We reference views by using their name, if they have a name. And so stock, if I have in variables tag, I have the stock. I can say my name in the views tag. I have a view that has my stock in it also. And so this is the equation, and this is the actual representation of it on the screen. If they don't have a name, then we use a unique identifier, and these are unique per XMILE model. Some common attributes, I'll just run through these quick. For displaying, we have border width, color, style, family, font style, font weight, text decoration, things like this. So these are kind of common things you'd see: padding, color, background color, z-index. These are common things you might see in CSS as well. The cascading style system allows us to have a style block at a high level that represents all of the things that are common. So the common styles I use throughout it, and then it looks, there's a picture. Not really. There isn't really a picture. But if I have a style for something that says, so stocks are bold, the font weight should be bold, and the color should be black by default. If I don't have that information for that object, then it will use this. But I can use information for that object to override it. I can also have a style in the views that can override it. And there are also defaults to fall back on it. So it cascades back. This simple model here for display purposes, so here's our variables. So we have a style here that tells us that we want these to be blue by default. We want things to be blue by default in a font size of 9 in Arial. And then I have my stock flow view here. I have the stock. I have its position and size. The flow. The flow has points from here to here that tell me where it is. I have the position of this auxiliary. I have this connector, and it tells me where it's going and from where to where, and its position as well. That's a representation. At this point, are there any questions? I just want to tell everyone that the OASIS vote opens right after Thanksgiving, and please vote. Please join us for any meetings. If you'd like to join our committee, please feel free to and help us. And at this point, I'm turning over questions to Dee.
Thank you so much, Fran. That was great. So we actually do have a couple of different questions. I think the first question, and you touched on this, which vendors have actually implemented XMILE or have plans to do so?
At this point, IC Systems has implemented XMILE. Insight Maker has implemented XMILE. There is an open standards group that's gotten together in the last 6 months who have implemented a subset of XMILE. That conforms. So I think it's the small subset that conforms at this point, but they're looking to expand it. And Ventana Systems is planning to implement XMILE. It's in their direction to do it, and Foreo at some point is also planning to implement it.
Okay, so that's quite a number. Okay, so here's some more technical questions. Is SD model quality benchmark, such as certainty borders, correctness, computer costs, etc., part of the OASIS XMILE effort?
So certainty, SD certainty. So XMILE, the goal of XMILE is not to influence the modeling practice per se, but it is to represent these models in a standard way in which they can be shared. The practice itself, so for example, if you want to talk about certainty of models and including that information, that would be, to me, I would include that as metadata at this point. As far as the process for determining certainty and validity of the model, that is, there are many processes within system dynamics that help you do that, but there's nothing in an XML representation that would specifically aid that.
Okay, and here we have another question. Can SD models be produced by ML algorithms trained over fax data extracted from data leaks or data warehouses and event streams?
Wow.
Right.
Can you ask that again?
Okay. And hopefully I'm data lakes maybe, so maybe that'll change. I was assuming, again, working on the cyber stuff, I'm assuming it's a data leak, so let me try data lakes. Is that a familiar term to you? It's not to me.
No, it's not, and I'm not sure what they meant by ML unless they meant the programming language ML.
I'm assuming that that's it. Well, since we put it out there, let's see if they come back and ask maybe in a way that we can answer. I appreciate the question. Here's another good question. Is the main purpose to enable correlation and integration?
So correlation is something that's very different from system dynamics. Since correlation is a statistical concept, and system dynamics, we look at cause and effect directly. So we're trying to look at causation. We're trying to build our models based on our ideas of causation or our theories of causation. And so they're more process-based models if you think about that instead of statistical models in that sense.
Okay. Okay, so let's just give everyone a couple more 30 seconds more to ask any more questions. Steve Cream, any parting shots? Any further information you would like to share with us as we wind down?
Well, I wasn't sure about that other question, but go ahead, Steve.
Yeah, I just wanted to say that there was a question earlier about which firms had implemented XMILE and are going to. And I wanted to state that at IBM, we work with system dynamics models, our research group. We have a team in IBM Research that creates system dynamics models, and we are very excited about the XMILE standard, and we look forward to taking advantage of XMILE in our system dynamics work. We look forward to it because it provides better documentation of what's in a model, and we look forward to it because it provides greater reuse. So we're very excited about the idea of taking advantage of system dynamics model libraries that the XMILE standard will provide. This will make it faster and easier for us to create and reuse models, as well as to explain how models work between different modelers. And that's why we're supporting the standard and the standard development.
Very good, thank you. We did get one more question to come in. I know this happens to me after a webinar. I think of something and it occurs to me. I will be sending a link to everyone that has attended today with a recorded version and my contact information. Feel free to send me the question and I will pass it on to the technical committee. Our one more question is, how do you validate if the model is correct?
So again, that is outside the range of the XMILE spec. That has to do with system dynamics practice, and it's fairly complicated, but there's a very specific process we follow to validate it depending upon what the purpose of the model is. And that starts from a simple level as does it really represent what we believe the theory is behind this system and the process behind the system, and then goes all the way to the other extreme of validating behavior against past events and past data.
Okay, well that looks like it. Again, I will be following up with a link to the recorded version. On behalf of OASIS, I would like to thank Stephen Cream, and I'd also like to thank all of our attendees for sharing some time with us today. Thank you so much, guys.
Thank you, Dee.
You're welcome. Bye-bye.